Hi everyone again and welcome to our last module on the high voltage and safety course. Today we will be exploring the safety features that are included in the electric vehicles and focusing on how the manufacturers design the electric vehicles to protect the drivers, the passengers, the technicians and the first responders. We will take a look on the different systems that are used and how they work, as well as why they are so important. This is the agenda of our section, our module. We will discuss these four main safety mechanisms for high voltage wiring and disconnect. We will review the high voltage interlock systems, the contactors, pyrotechnic disconnects, and the fuses. In general, in modern electric vehicles, we incorporate several layers of safety to handle the high voltage system and to power the drivetrains in a safe manner. These mechanisms will ensure that we have a safe operation, that during normal everyday driving we have the minimal risk. They also ensure that there is protected maintenance, that there are clear procedures and fail-safe for technicians so they can do their work without any fear or shock, and also that quick responses are protected so that we have automatic disconnections during crashes or electrical faults. In a case of an emergency response, the system is as safe as possible. In the rest of this module, we will break down the four main systems that are used as protection layers in our high voltage system. We have the high voltage interlock, contactors, pyrotechnic disconnect, and fuses. We will understand how they work together to safeguard the people and also the vehicle. And let's move now then into the high voltage interlock system. Here we will see how this can help us to ensure that no one accidentally comes into contact with a high voltage component or wiring. So we will talk about how it functions and the different types of interlock loops that are used today. So, what is the high voltage interlock system? This is going to be a critical safety feature that currently is found in almost every electric vehicle, and basically it is designed to protect individuals during the assembly, the repair of the maintenance, and even during the operation of the vehicle by preventing the accidental contact with the high voltage components. In this case, whenever someone opens a high voltage connector or accesses the battery enclosure, for instance, the high voltage interloop loop will detect the break in the low voltage circuit that it has, and this will cause the system to immediately shut down and to prevent the activation of the high voltage supply. It is very important because if a technician, for instance, inadvertently disconnects a cable without powering it down, the high voltage interlock ensures that the rest of the system is going to be de-energized, and in general this will reduce the risk of shock. How it is implemented? Usually it is implemented in the connectors, as you can see over here. This connector has the power pads that are high voltage, but in addition to those high voltage pins, they include, as you can see here internally, they include a low voltage circuit. Whenever we detect or this low voltage circuit is open, we can detect that the connector is pulled out, and we detect that the circuit is broken, and in such a way we de-energize the system. So this keeps everyone safe, from the assembly workers in the factory to the service personnel that is in the field. The high voltage interlock becomes crucial whenever the EV systems operate at high voltage. It means above 60 volts DC. voltage higher enough to pose shock hazard require this high voltage interlock to be included. Typically in low voltage hybrid systems, for instance those that are working at 12 volts or 24 volts, do not require this interlock to be implemented because their voltage level are not as dangerous or are not dangerous enough. They are going to be implemented then in the electric or hybrid or fuel cells vehicles, and in those cases it is mandatory to have the high voltage interlock. In any of these cases, if the high voltage interlock sends an authorized and non-authorized opening or tampering, it will cut automatically the power in the vehicle, and this is going to be essential, as was mentioned, for the technicians and for anybody that will be working with the high voltage system. This diagram represents how the high voltage interlock system works. So you have to think on the high voltage interlock as a continuous low voltage loop that is going to be running alongside the high voltage components cable, and that basically is a loop that goes through all of our high voltage components. It is starting from the battery management system. As you can see over here, it is this loop that you can see over here. So there is the high voltage interlock loop that goes from the BMS, then it comes here to the drive inverter, to the motor, comes out, and the same loop goes into the onboard charger, then it goes into the high voltage monitoring unit and goes through any other DC-DC converter or any other system that is connected to the high voltage loop. In this case, as was mentioned, when any of these if at any of these systems this loop is opened, it will detect a signal that the loop has been interrupted, and this indicates that has been an issue with the high voltage system, and that has to be addressed by disconnecting and de-energizing the system. As you can see, in some cases we have this high voltage interlock monitoring unit. It can be included in the battery management system or can be external, and this is the system that looks for the continuity in the loop. It basically delivers a constant current, and then the current is measured in the return. If the current is not if we measure the current lower than certain threshold, we can predict that there is a problem in the high voltage loop. If any break occurs, the diagnostic trouble code is triggered, and in those cases the driver sees an alert or the high voltage contactors open to insulate the battery from the rest of the system. This approach is very important because it prevents accidental exposure and ensures that any initial disruption is cut early enough, and it is a very effective principle that if the circuit is not complete, high voltage cannot flow. Currently, there are different types of interlocks circuits that we can see. Here are 4 of the different interlock systems. We have first the series interlock loop, that this is basically a daisy chain approach that is monitored by the BMS, and in this case, if any link in the chain is broken, the high voltage battery relays will be open or the contactors will be open. We also have the localized interlock loop. This means that each component in our high voltage loop can individually monitor the status of the high voltage path, and it can then control individual components based on that. Another one is the grounded switch interlock system. This uses grounded switches to detect faults quickly. and this is going to be done by the BMS or by hybrid controllers. And basically here we will disconnect the relays and the discharge capacitors based on these decisions. And finally, we also have the high voltage interlock circuit, that is the one that we explained before. In this case, we have a series circuit type that is controlled by the high voltage powertrain control mode. And in this case, we also will open the high voltage contactor if there is any failure. Regarding the design that we are using for implementing the interlock, all of them share the same goal, that is to automatic and immediately disconnect if there are unauthorized opening or a fault in the high voltage system. It is a very simple approach, but and modular, and it helps to easily tailor any failure and to be implemented also easily into different vehicle architectures and following different safety standards. Now, there is another component that is very important, that are the contactors. Let's explore how the contactors help us with the safety. So, high voltage contactors are going to be essentially electromechanical relays or switches that are designed to handle very large currents in the electric vehicles. These will act as a crucial safety gate between the battery and the vehicle electrical system. So whenever we have any crash detection or when we need a fast response, in those cases, the system will detect a safety issue, for instance, a serious impact, and they will signal the contactors to open in such a way that we insulate the battery, and this will reduce the risk of post-collision fires and electric shocks. Also, these contactors will be open based on the decisions of our battery management system and based on the electrical fault detections. So the battery management system is going to be monitoring all the electrical conditions and thermal conditions of the battery, like overcurrent, over voltages, short circuits, and other faults. And on the detection of any of these protections, it will command the contactors to open, stopping the current flow and limiting the damage of the system. In general, without the contactors, it would be way much harder to disconnect rapidly our high voltage battery system in the case of emergency, of when we were making protections based on our BMS decision. So the contactors are a critical element of safety in our systems. Usually this contactor you can have redundancy, so to have more of one contactor in parallel. In case that one contactor fails, the other contactor will still open and disconnect the batteries. All of those are different approaches that keep our vehicle as safe as possible. The contactors, as was mentioned, will provide a quick will behave as a quick acting switch, but in some extreme scenarios, like in severe crashes or in very, very hard conditions, we might also use the pyrotechnic disconnects. These are even faster, and also they are a more definitive break in our high voltage system. So let's see how they work and when they are necessary. So this pyrotechnic disconnect, also known as the pyrofuses or pyrotechnic safety switches, they will act like little tiny explosive charges that instantly and permanently will disconnect the battery from any hazard in the system. So what is the activation mechanism? Typically, these pyrotechnic switches are tied, for instance, into the airbag control or to the BMS control. And when we have any critical fault or severe impact is detected, there is a small explosive charge that fires inside, and that will break down the high voltage link. As you can see, this will be a physical disconnection, and because of that, it is going to be a permanent disconnection. It's not the contactors on the opposite side. You can command them to turn off, and later, when there is a safe, when you return to a safe state, you can command them to get on again. In the case of the pyrotechnic switches, it is not possible. The circuit is permanently de-energized. What are the safety benefits of this? The first one is that it completely eliminates the chance of re-energize the circuit, because, as I mentioned, it is permanent, and also it will prevent fires, thermal runaway, electric shock from the occupants and the first responders as well, by disconnecting the batteries from the loads. Because these pyrotechnic switches operate in less than few milliseconds, they are especially valuable in high voltage systems that are above 400 volts, where we need the speed, and when certainly the disconnection happening faster can really make the difference. And our final mechanism is going to be the fuse. The fuse is the classic protective device that in this case is going to be adapted for high voltage electric vehicle systems, and we will explore how they work and how they are integrated in our powertrain. Usually fuses are underrated. We have them in all of the systems, including in EVs, but are a crucial part on the safety of the high voltage EV systems. They are very important in the role of interrupting the system in the case of excessive current flows. When we analyze the fuses, in general, we have 3 conditions. The first one is the normal operation. In the normal operation, the fuse will allow the current flow within the safe limits, and when the current exceeds the fuse rated capacity, then in this case the fuse element that is inside will melt and it will break the circuit. Also, we have the condition that is the overload condition. In this case, when we have current spikes that are above the fuse ratings, in those cases the fuse elements will heat up, and also it will melt and will break down the circuit. And the once that happens, then we have the blown fuse. The circuit in this stage is now open, and this will protect the rest of the EV electrical components from potential short circuit or voltage spikes and so on. We usually use in this type of systems high-speed fuses that will react in milliseconds, and this ensures that the battery, for instance, short circuits are rapidly contained. And when we think about the fuses, we have to think like they are very important for protecting the battery from overcurrents that have to be we have to react fast in those conditions. In general, EV fuses are classified mainly based on the voltage rating and the current rating. We have, for instance, fuses that are going to be working on the auxiliary or in the onboard charger. These are fuses that are having lower amperage, often between 5 and 25 amperes or between 30 and 60 amperes, and they are used in the peripheral components that are operating in the battery system, from few volts to 1000 volts depending on the system. Besides of these auxiliary systems, we can also have fuses in the main protection path and in the DC fast charging. These mid-range fuses will typically handle voltages between 500 1000 volts, and the current can goes up to 600 amps depending on the architecture of the vehicle. And finally, we can also have some larger fuses that can go up to 1000 amperes that are used, for instance, in heavy duty and high capacity battery packs. We have different manufacturers here. For instance, we have Eaton, Littelfuse, and some others that provide specifically designed fuses for electric vehicles, and these specific fuses are capable of withstand the thermal cycling, the vibration stress, and the environmental conditions of the electric vehicles. So when we are selecting those, we have to ensure that they're going to be stable for the system that we are targeting, and that they can finally fulfill the goal, that is to prevent catastrophic damage if something goes wrong because of high current amperage. So thank you very much for taking the time of taking this safety and high voltage course. This is the last of our modules. I expect that you have enjoyed the course with us and that gives you enough information to keep you safe and to keep also the people around us safe and well trained about the considerations of high voltage systems.